welcome to the next tutorial class. So, that is on the power flow in a rectangular waveguide. We will continue from the previous class. So, we have for the T to Z mode. So, our problem is an air filled rectangular waveguide has cross sectional dimension A equal to 6 and B equal to 3. So, here E z is given. So, that means it is for the TM to Z mode, because here electric field is given, Ez is given, that means no magnetic field is given. So, Hz will be 0 and this is for the Tm to Z mode. So, we have computed the field expression for the T to Z mode, Tm to Z mode, and here we can calculate also for the T to Z mode. For the T to Z mode, Hz will be this. So, this is the standard format for the Hz, h naught cos m pi x by a cos n pi by b into e to the power minus gamma z into means that, and E z will be 0. So, Ex can be written as minus of j omega mu divided with h square del of Hz by del y. So, this will come minus of j omega mu h square. So, this is the partial differentiation on y. So, n pi by b will come outside, n pi by b cos of m pi x by a, and here means differentiation with respect to y. So, it will give that it will give the minus sign, and this will be plus, because minus cos differentiation of cos will be minus sign. So, that will be sin of n pi by b e to the power minus of gamma z. So, this is for the Ex, and Ey will be j omega mu divided with h square del of Hz upon del x. This will be j omega mu. So, this will be with minus sign h square with x. So, m pi by a h m pi by a h naught sin of m pi x by a cos of n pi by b e to the power minus gamma z. So, this will be the Ey. Similarly, we can calculate the Hx and Hy. Hx will be minus of gamma h square. This is for the T to Z mode. So, in terms of Hz, all the field expression will come del of del Hz into del x, it will equal to gamma by h square m pi by a h naught. So, difference sign m pi x by a cos n pi by b e to the power minus z. So, Hx will be this, and Hy will be minus of gamma h square del of Hz by del y equal to gamma by h square differentiation with respect to y. So, n pi by b h naught cos of m pi x by a sin of n pi by b e to the power minus gamma z. So, we have written all the field expression, means Ex, Ey, Hx, Hy, Hz is already given in the first, and Ez will be 0 for T to Z mode. Now, we can come to the problem. In the problem it is given Ez is equal to 5 sin 2 pi x by a sin 3 pi by b cos 10 to the power 12 t minus beta z. We can compare this with our standard equation. So, there Ez we have Ez is equal to E naught sin m pi x by a sin n pi by b. So, after comparing from this we will get m equal to 2 and n is equal to 3, and because Ez is given. So, this will be so Tm to Tm3 to Tm23 mode. So, this will be Tm23. And calculate the first we will calculate the intrinsic impedance of this mode. So, we identified the mode, that is Tm23, and for Tm23 mode we will calculate the wave impedance, intrinsic wave impedance for Tm23. For Tm23 mode we will calculate the eta. So, for the Tm mode, eta Tm we know eta 1 minus Fc upon F whole square. So, this is the formula to calculate the impedance. So, eta will be, and here we have to see that. So, what is the means eta is, it is free space, it is given air filled rectangular waveguide. So, if it is air filled, then there is no problem. So, eta will be 120 pi or 377 ohm. So, Fc we can calculate, Fc will be u by 2 a square root of m by a whole square plus n by b whole square. Because this is air filled, so u will be c, that is same as the velocity of light, that is 3 into 10 to the power 8 by 2 a square root of, and because this is for the Tm23. So, this m will be 2, and n will be 3. So, we can substitute a is 6 centimeter. So, 6 into 10 to the power minus 2. So, this will be whole square plus inside the bracket 3 by, that is 3 centimeter, 3 into 10 to the power minus 2 whole square. This is also inside the bracket. So, after calculation we will get Fc for Tm23 that is 15.81 gigahertz. So, Fc23 is 15.81 gigahertz. So, now we know eta Fc and F is given, yes, F we can calculate. In the expression we can see that cos omega t minus beta z, that means omega is 10 to the power 12. So, F we can calculate from this, F will be omega is 10 to the power 12. So, F, because omega is 2 pi f equal to 10 to the power 12, F will be 10 to the power 12 divided with 2 pi. So, this is the operating frequency. So, this will come 159.2 gigahertz. So, this is in the millimeter wave range. So, for this we can calculate the eta. Eta will be, this is for the eta Tm23 equal to eta a square root of 1 minus Fc upon F whole square equal to 377 a square root of 1 minus 150 that Fc. So, Fc we have calculated 15.81 divided with operating frequency is 159.2 159.2, that is operating frequency and whole square. This will give 375.1 ohm. So, this is the solution for the first part. Calculate the intrinsic impedance of this mode and average power flow in the guide. Now, we have to calculate the average power flow in the guide for this mode, that is also mode dependent. So, power average, to determine the power average flow in the guide, we have to use the previous expression. So, power average inside that can be calculated as equal to 1 by 2 real part of E cross H star like this into ds, like this. From this means formula we can calculate the power flow in a rectangular waveguide. So, first we can calculate this E cross H star will be Ax A by Az. So, Ex will be Ex E by Ez, because this is for the Tm to Z mode, means Tm to Z mode. So, that and this is star. So, Hx star, Hy star, and Az will be 0, because this is for the Tm to Z mode. So, this will be E cross H star, and after calculation we will get, we can take X common. So, 0 this into this, 0 minus Ez Hy star plus A by this minus this Ez Hx star minus 0 plus Az Ex Hy star minus E by Hx star. So, this is the E cross H star, and ds is defined as, because this is rectangular waveguide, that is along the z direction. So, ds for this case will be defined as dx dy into Az. So, either can use either Az or uz, that with cap. So, ds will be dx dy into Az. So, if we will substitute that, means dx dy Az. So, with the dot product here. So, here this first part Ax and second part A by, with Az dot product it will be 0, because theta will be 90 degree, that means this cos 90 0, and answer will come, it will only there, means finite will be only this Az dot with Az. Here angle will be 0 and cos 0 1. So, here means we will get the power average. Power average will be 1 by 2 real part of this last part only, Ex Hy star minus E by Hx star, and that has Az into dx dy into Az. So, Az dot product, this will be 1, and we will get, and here we can calculate, means we know eta equal to Ex upon Hy and eta equal to minus of Ey cross Ey upon Hx. So, we can substitute here, means Hy star, means Hy equal to Ex upon eta. So, it will be Ex star upon eta. So, that means Ex into Ex star. So, that means mod of Ex square, and here we will substitute Hx star. So, that will be E by that will be E by star minus of E by star divided with eta, and E by into E by star, that will be mod of E by whole square. So, from this, after substituting this, and we will get power average power average will be 1 by 2, and this is the integration on dx and dy. So, we can keep we will do first by and then x is equal to 0 to a, y equal to 0 to b, mod of ex square plus mod of e by square divided with eta dy into dx. And we have calculated that a standard format of this means ex and ey. So, ex and ey, there it was means ex was, we can write ex was minus of j beta divided with h square m pi by a e naught cos of 2 pi x. Here it is m is equal to 2, means m is replaced with 2 pi by 2 pi x into a, sin of n is 3 pi by b e to the power minus of j beta z, because this is for the propagating mode, e by equal to minus of j beta divided with h square n pi by b e naught sin of 2 pi x by a into cos of 3 pi by b into e to the power minus of j beta z. So, this is the ex and ey, and after the mod, so this part will be 1, this last part e to the power minus j beta z, in the mod it will be 1, and then ex square e by square, we can do the integration, and this can be, this will be means this will be 1 by 2 eta, that power average 2 eta Tm, that is for the into beta square E naught square. So, beta square E naught square, that is common, h to the power 4, and integrating x is equal to 0 to a, y equal to 0 to b, and inside the integration it will be 2 pi that m is 2, here it is 2. So, 2 pi a whole square, this will cos square 2 pi x by a, sin square 3 pi by b. Next n will be 3, it will be 3 and 3 pi by b whole square, and this is sin square 2 pi x into cos square 3 pi by b. So, it will be 2 pi a whole square cos square 2 pi x a into sin square 3 pi by b plus 3 pi by b whole square into sin square 2 pi x into cos square 3 pi by b, this, and this is inside the integration dy into dx. So, we know the integration. So, integration rule is means if x is equal to 0 to a, y is equal to, this is the general formula, x is equal to 0 to a, y is equal to 0 to b. So, cos square m pi x by a into sin square n pi by b into dy into dx. So, this is by equal to, so this can be written as 1 plus cos 2 m pi x by divided with 2, 1 minus cos 2 n pi by b divided with 2. So, 1 will be 1 by 2 1 by 2. So, this will give a by 2 and this will give b by 2 and total integration value will be a by 4. So, we can substitute all this value there in the upper equation. So, it will be 1 by 2 eta T m beta square E naught square divided with H 4 A b by 4, that is same in both the cases. So, it will come outside and inside the bracket 4 pi square a square, inside the bracket 4 pi square a square plus 9 pi square b square. Beta, now all are known. So, beta we have to calculate. Beta will be omega upon v. Omega upon v, that means omega upon v for the Tm is c into 1 minus f c upon f whole square equal to omega is known 10 to the power 12 divided with 3 into 10 to the power 8, a square root of 1 minus f c is 15.81. We have already calculated in the first part. Operating frequency is also known whole square. Gigahertz is cancel out. So, beta we will get from this 3.317 into 10 to the power 3. So, this is the value of beta and h square will be gamma square plus k square, that is equal to kx square plus ky square, that is equal to m pi a whole square plus n pi by b whole square. This will come 2 pi a whole square plus 3 pi by b whole square, and this will give 4 pi square divided by a square plus 9 pi square by b square. So, h square value is this one. So, we can see here. So, this is basically h square, total will be h square. So, this total is h square, that means we can cancel out h square, that is in the denominator h 4. So, it will be cancel out 1 h square, total expression, then power average will be beta E naught square a b by 8 eta T m, that is for the 2-3 mode, T m 2-3 mode into h square. Now, we can substitute all the value here, and by the way value for this will be a and b we can substitute, and this will be 1.097 into 10 to the power 5. So, this is the value of h square. We know eta T m, we know E naught, that is in the amplitude of the wave, that is 5. A b, we know a and b, a is 6 and b is 3 centimeter. So, this power average will be, we can substitute all this value. So, beta square, right. So, this is beta square. So, here it is beta square. So, it will be beta square. So, beta will be 3.317 into 10 to the power 3 whole square into 5 square, that is 25, into a into b, that is 6 into 3 18 centimeter minus 4, it is in the meter, divided with 8 into 375.1, that is we have computed in the first part eta T m 2-3 mode, into 1 point, that h square we have calculated 1.097 into 10 to the power 5. This will come 1.502 milliwatt. So, this is the final answer for this one, second part. the average power flow in the guide. So, this is the average power flow is 1.502 milliwatt. Now, next problem is for the TM11 mode, derive a formula for the average power transmitted down the guide. So, for the TM11 mode, we have to calculate the average power flow. Similar to the T mode, we can find out for the TM11 mode. For the TM11 mode, that is fourth part. For the TM11 mode, power average, we know it can be written as 2 eta. So, that will be for the TM11, 2 eta, that is y equal to 0 to b, or it can be interchanged, not a problem. X is equal to 0 to a Ex square plus Ey square into dx dy. So, this is the power average. Now, we can substitute, we have calculated the for the TM mode, we have calculated above all the expression, we can substitute here for the TM mode. So, this is for the TM mode, that is the second part. So, for the TM mode, Ex is, so Ex was, so Ex was for the 1 minus of j beta divided with h square. So, first one means third problem was for the TM23, but here it is for the TM11 minus j beta h square pi by a. So, for 1 m is equal to 1 cos of cos pi by x by a into sin of pi by b a to the power minus j beta z, and E by will be for m equal to 1 and n equal to 1 minus of j beta by h square pi by b E naught sin pi x by a cos pi by b e to the power minus of j beta z, e to the power minus j beta z. So, this is the Ex and E by, we can substitute the Ex and E by in the power average formula, and we will get power average equal to 1 by 2 eta TM11. So, it can be computed, and beta square divided with h4 pi square E naught square this, and this will be pi square is common, and then 1 by a square in the first part, and in the second part 1 by b square. So, it will be 1 by a square, that integration on 0 to a cos square pi x by a into dx into, now it is separate, two integral we can, because this is in the separate, no dependent term in the each other. So, it can be separate out, and 0 to a cos square pi x by a dx, and for the second part 0 to b sin square pi by b into dy plus 1 by b square, in the same way 0 to a sin square sin square pi x by a into dx 0 to b cos square pi by b into dy. So, this will come right. So, from this we will get 1 by 2 eta TM11 beta square pi square divided with h4 E naught square 1 by a square plus 1 by b square, and both the integral, that will give a by 2 b by 2, and in the outside it will be a by 4 we have taken. And because h square is pi square by a square, because h square is pi square by a square plus pi square by b square. So, this will be a square plus b square by a square b square into pi square. We can substitute all this value there, and we will get power average. We will get power average equal to 1 by 2 eta Tm 11 beta square, that is eta naught whole square by h square into AB by 4, because h square 1 is cancel out, pi square is going inside. After substituting, we will get we can substitute the value of h square, and this we can substitute 1 by 2 eta Tm 11. So, beta square E naught square AB upon 4. H square will be a square b square will go in the upper side, and then a square b square common with pi square. So, a square b square divided with a square b square into pi square. So, final means power flow for the Tm11 mode, it will be beta square E naught square a q b q divided with 8 pi square eta Tm 11 divided with means a square plus b square. So, this is the average power flow in the waveguide. So, like this we can calculate the means for the T mode also, just have to compute the means have to give the Ex and Ey expression, and for the T mode either in the Hx we can obtain this expression in terms of Hx and Hy also. So, for this we have to means give the means we have to substitute the formula, and it will give the answer. So, next part is, so we can see the next problem. A rectangular waveguide with A equal to 2b equal to 4.8 centimeter is filled with Teflon with epsilon r equal to 2.1. So, rectangular waveguide A equal to 4.8 centimeter, B is 2.4 centimeter, because B will be A by 2, is filled with Teflon with epsilon r equal to 2.1, and loss tangent means that has some lossy, that is filled with means waveguide is filled with lossy material that has permittivity 2.1 and loss tangent is 3 into 10 to the power minus 4. Assume that the wall of the waveguide are coated with gold. So, that has some conductivity, finite conductivity, that is 4.1 into 10 to the power 7 per meter, and that a T10 wave means that a T10 wave at 4 gigahertz propagates down the waveguide. Now, means T10 wave means a wave is propagating inside the waveguide at 4 gigahertz. So, find the alpha d and alpha c. So, we have to find out the attenuation alpha d and alpha c in this case. So, we know means power flow in the waveguide, power flow in the waveguide, that is power average equal to P naught to the power minus of 2 alpha z. So, this is the power flow in the waveguide with attenuation. So, like this attenuation power flow in the waveguide. So, and time average power loss per unit length can be calculated as minus of d power average by d upon dz. So, from this we will get 2 alpha into power average. So, alpha we will get alpha from here we will get PL upon 2 into power average. From this we will get the alpha. So, and alpha can be written as alpha c plus alpha d. So, total means alpha d. Here alpha c the attenuation constant due to ohmic or conduction loss, that means sigma c, that is not infinity, and alpha d the attenuation constant due to the dielectric loss. So, this is due to the wall and this is due to the dielectric. So, we know means alpha we know, alpha means gamma is defined as alpha d plus j beta d, and this can be written as, so this is the derivation for the alpha d, how it can be defined. So, gamma it can be defined as m pi by a whole square plus n pi by b whole square minus omega square mu epsilon, and here epsilon is defined as epsilon prime minus j, one is real part, imaginary part, and this can be written as epsilon minus j of sigma by omega. So, this epsilon we can substitute here, and after substitute means we have to substitute this alpha into there, and after substitution we will get, so this square root will come on this alpha d plus j beta d whole square, and this will come means alpha d plus j beta d whole square, this will be m pi a whole square plus n pi b whole square minus omega square mu epsilon minus j of sigma by omega. So, this will come, and this alpha d plus j beta d we can write like this, alpha d whole square minus beta d whole square, because this j square will give minus 1, beta d whole square plus 2j alpha d into beta d equal to m pi a whole square plus n pi b whole square minus omega square mu epsilon plus j omega square j and this omega will cancel out, and this will be j omega mu sigma. So, this will be there. Now, we can equate real and imaginary part both side. So, real part in the left side will be equal to the real part on the right side, and this will be alpha d whole square minus beta d whole square equal to m pi a whole square plus n pi b whole square minus omega square mu epsilon, and imaginary part will be 2 into alpha d into beta d equal to omega mu into sigma. From this means from the second equation we will get alpha d equal to omega mu sigma by 2 beta d, and we can assume that alpha d is very less than, means alpha d whole square is very less than beta d whole square, because beta d is the propagation constant and we want minimum attenuation, means minimum loss. We use the waveguide as a power flow to send the power from one place to another place. So, we can assume that attenuation is that constant inside the dielectric, that is very small, and beta is frequency dependent. So, it will come in the very large compared to the alpha d. So, from this, if alpha d is very small, so we can write this expression, means this expression. So, this will be negligible, means this will cancel out compared to beta d, and this will be beta d. We can write a square root of one step, we can write more, otherwise it will be confusing. Minus of beta d whole square, it will be m pi a whole square plus n pi b whole square minus omega square mu epsilon. So, this will be there. Now, we can cancel out, minus sign will come this side. So, this minus sign. So, this omega square mu epsilon will come first, and beta d will be a square root of omega square mu epsilon minus m pi a by whole square plus n pi by b whole square. So, this will be the value of this beta d, and this can be written as a square root of omega mu epsilon 1 minus f c upon f whole square. So, this will be the value of beta d, and from this beta d we can substitute here, and we will get alpha d as sigma eta divided 2 1 minus f c upon f whole square. So, this from this we will get the alpha d, and alpha c means I am not deriving, alpha c expression is 2 r s divided with b eta 1 minus f c upon f whole square, that is 1 by 2 plus b by a f c upon f whole square. So, this will be the value of alpha c, and here R s is the skin resistance of the valve. So, R s is the skin resistance, and R s can be written as 1 by sigma c into del, and del is the skin depth, that is 1 minus pi f mu sigma. So, from here and f c will be f c, that is the cutoff frequency, and f c will be, because this is for the T10, right. This is for the T10 mode, and operating frequency is 4 gigahertz. So, for the T10 mode, f c will be c upon 2a root under epsilon r So, it will be 3 into 10 to the power 8 divided with 2 into 4.8 into 10 to the power minus 2 into a square root of 2.11. So, this will come 2.151 gigahertz. So, this is the value of f c. So, in the a part means we can calculate loss tangent, and then d means we have to calculate the alpha d and alpha c. So, we have the formula. Now, we can calculate the alpha d and alpha c. So, alpha d is sigma eta divided with 2 a square root of 1 minus f c by f whole square. So, loss tangent we have loss tangent means for the a part alpha d, loss tangent is defined as sigma by omega epsilon. So, sigma by omega epsilon, and loss tangent is given in the this it is given, loss tangent is given, loss tangent is given. So, we will get the sigma from here. So, sigma will be loss tangent into omega epsilon. So, this will come 3 into 10 to the power minus 4 into 2 pi into 4 into 10 to the power 9 into 2.11 into 1 by 36 pi into 10 to the power minus 9. So, it will come 1.407 into 10 to the power minus 4 Siemens per meter. So, this is for the sigma C. So, we will continue this in the next class. Thank you.